Now let's take a look at the law of cosines. You will find law of cosines particularly helpful when you're trying to find the angles of a given oblique triangle with only sides given, or sides and angles but the angle that's the largest is not given. Here is the list of formulas that will help you find the correct angle you're looking for. Side A squared equals side B squared plus side C squared minus 2BC cosine of angle A. Side B squared equals side A squared plus side C squared minus 2AC cosine of B. And C squared, side C squared, equals A squared plus B squared minus 2AB cosine of angle C. In any three of these cases, we can solve for the angle A, B, or C given whichever side has the longest dimension will then imply which angle is the largest. So if I were to look at the example here, we see that A is 42.3 degrees, and we don't know the opposite side. If I wanted to find the opposite side, I could just say A is equal to the square root of everything on the right in the first formula. So I would substitute values in for B squared plus C squared minus 2BC cosine of A. This will give me the square root of 12.9 quantity squared plus 15.4 quantity squared minus 2 times 12.9 times 15.4, all multiplied by cosine of 42.3 degrees. The side A comes out to be 10.5. So clearly C is the longest side, which means angle C will be the longest or largest angle. And so we then can solve for cosine of C, which can be done by bringing everything else to the left side. So we'll use the third equation here, or formula, to find angle C. Cosine C is equal to C squared minus A squared plus B squared, all divided by negative 2AB. At this point, I want to mention that I need to divide everything in the numerator by a negative 1, and by doing so it will change all the signs in the numerator. And I'm going to go ahead and rearrange the terms once I've divided in that negative 1. So now I have the angle C is equal to the inverse cosine of, in the numerator, A squared plus B squared minus C squared, all over 2AB. I'll go ahead and substitute the values in. A is 10.5 squared plus B is 12.9 squared, and subtract 15.4, that's C squared, all divided by 2 times A, which is 10.5, times B, which is 12.9. Make sure your calculator is in degrees and find out what the angle C is. I get the angle C is 81.6 degrees. From here, we can find any of our other sides and angles. I'll go ahead and fill in what I know so far. I know that A is 42.3 degrees. I know that C, angle C, is 81.6 degrees, and so using 180 minus A minus C, I get 56.1 degrees for the other side. Now, at this point, we have all the sides and all the angles, but you may be asking yourself, why is she doing all this stuff? Why doesn't she just use the law of sines? I totally could, but I want you to see how to use the formulas here, and then you can pick and choose when it's better to use law of sines and when it's better to use law of cosines. In this second example, we have sides only given, and so we need to figure out which formula would be best given that side A is 9.47, side B is 15.9, and side C is 21.1. This tells me that the side opposite the angle will determine which angle is the largest. I've fortunately already solved for C once today, since the side opposite the angle that is the largest will be the longest side. C is going to be equal to cos inverse of the information here. We have a squared plus b squared minus c squared all divided by 2ab will give us the guts of the cos inverse. So I'll have 9.47 squared plus 15.9 squared minus 21.1 squared, all divided by 2 times 9.47 times b, which is 15.9. Remember, I'm staying in degree mode. And my angle for C is equal to 109.94, so I'll just go to one decimal place here. 109.9 degrees. So here are the basic concepts that we've covered so far. If you have an oblique triangle, you could have a side angle angle or an angle side angle given, and we suggest that the procedure to follow to solve for the angles and the sides would be 1, to find the remaining angle using an angle sum formula, and 2, find the remaining sides using the law of sines. For a side-side angle, be aware of the ambiguous case where there may be two triangles, and in this process, step 1 would be find an angle using the law of sines. 2, find the remaining angle using angle sum formula, and 3, find the remaining sides using the law of sines. If 2 angles exist, repeat steps 2 and 3. In a case where you're given an angle formed by the two sides given, or side angle side, you need to find the third side using the law of cosines. Find the smaller of the two remaining angles using the law of sines, and finally 3, find the remaining angle using angle sum formula. And the last one is the easiest one to identify as a law of cosine one because it's side, side, side. So you're given only sides, no angles. So 1, find the largest angle using the law of cosines. 2, find either remaining angles using the law of sines. And then finally 3, find the remaining angle using angle sum formulas.